right, we are recording. I do want to remind you of what the last 2 weeks of our course is going to look like. I will, of course, put out another announcement on Monday for week 16. This week, you should be finishing up chapters 5 and 6. We did finish chapter 6 last Thursday, and your last chapter exam is due on Tuesday, May the 10th at 5 o'clock. And that chapter exam does cover chapters 5 and 6 on solving systems of equations. Your final is due 1 week from today at midnight. You cannot take the final after the due date. The final must be submitted by midnight on Thursday, May the 12th. If you do not have your final submitted by midnight, Thursday, May the 12th, you will receive a 0 on it. Graduation is May the 13th. It is the next day. I have the weekend to get grades together and submitted. So I do not have the opportunity to let you take the final late. I can't do it. I have to get grades done. I have 8 classes this semester, and I do have quite a bit of grading to do to get final grades submitted. Also note in this announcement that there is a formula sheet specifically for the final. It's much shorter than the notes I've been giving you for each chapter. It's more concise, and I think you'll find it quite handy. It's just 2 pages or 1 page front and back if you print it off. All right, so with that, let's go ahead and get started, and let's review for the final. So we are going to cover the 18 questions that are on your final. There are 30 questions on your final review. We're going to cover the 18 specific questions that are on the final. All right, the first question that is on your final is question 1 on your review, dividing complex numbers. And as you recall, to divide complex numbers, you multiply by the conjugate of the denominator. And you do that because when you multiply a complex number by its conjugate, you get a real number. That's what you get. So we're going to multiply numerator and denominator by 9 plus 7i. So the conjugate of the denominator, all we do is change the sign of the imaginary part, and that's the conjugate. All right, so we're going to distribute the 3i across the numerator. And when I multiply a complex number by its conjugate, it is real, and it is the sum of the 2 squares. So I take the 9 and I square it. And I take the 7 and I square it. And I add those 2 things together. Okay, so what do I get? Let's distribute that 3i across. So I get 27i plus 21i squared divided by 81 plus 49. And that's going to be 27i. I squared is equal to the real number, -1. So that's going to be minus 21 over 130. And now we're going to write this in standard form, which it does tell me to write this in standard form. So I'm going to write the real part first and the imaginary part second. And that is the solution to that one. It's being slow. Plus 27 over 130i. There it goes. All right. The next question we're going to cover on your final review is problem 5 on on solving absolute value inequalities. And as you recall, the absolute value is a distance. It's the distance a number is from 0 on the number line. So where on the number line is the distance greater than 8? Well, that would be everything to the left of -8 or everything to the right of +8. So we take the stuff inside the absolute value bars. We set that less than -8. We take that stuff inside the absolute value bars and we set it greater than +8. However you think you want to do this problem, don't do that. Do it the way I'm telling you to do it. Take that stuff inside absolute value, set it less than the negative, set it greater than the positive. Solve the two inequalities. Okay, so x is less than -3, or add 2 over here. Divide by 2, x is greater than 5. And they do tell you to write this in interval notation. This is set builder notation. So we're going to go ahead and write the intervals. Everything to the left of -3 would be from -infinity to -3. Union with everything greater than 5 would be everything to the right of 5, 5 to infinity. All right, the next problem we're going to cover is problem 6. This is an absolute value function, and I know it's an absolute value function because it's one of my 7 basic functions. And when you have that V-shaped, it is an absolute value function. And as a matter of fact, I could probably figure out what the equation to this thing is because it's been shifted 1 unit to the right and 4 units up. So I probably could write the equation for this thing. So it's been shifted 1 unit to the right. So that'd be x minus 1 and 4 units up. Hopefully we've learned at least from, oops, sorry about that. From so far this semester that we can write the equation if we know the transformation, or if we know the equation, we know the transformation. All right, what's the function's domain? What's the domain of every absolute value function? The domain of every absolute value function is a set of all real numbers. There is no number I can't plug in for x. Any real number I can plug in, subtract 1, take the absolute value and add 4. What's the function's range? Well, since this is an absolute value function that opens up, the range is going to start at that lowest point, that minimum, and go to infinity. And what's that minimum? That minimum is 4. So we're going to have a range that goes from 4 to infinity. And you'll notice that I did use a bracket next to the 4 because 4 is a point on that graph, and it is a point that is included in my range. All right, what are the x-intercepts? Doesn't look like it has any to me, not crossing the x-axis anywhere. What's the y-intercept? Well, can you see that on the screen? It looks like it's crossing the y-axis at 5. So the y-intercept is 5. And then they ask me to evaluate the function at 0 and 2. So what's y when x is 0? What is y when x is 2? And I already figured out what y is when x is 0. That's the y-intercept. So f of 0 is 4. And I do believe for this particular problem, what do we have for 2? I'm going to blow it up for a second, if it'll let me. It's not gonna help. They're not gonna let me do it very well. I'm trying to use Adobe Acrobat and it's not cooperating. All right, well, you would be able to blow it up on the screen in my math lab, but at x is 2, oh, what did I say? See, I'm gonna blame the cold. I'm gonna blame the cold. The y-intercept is 5. I tell you what, since when the weather came in on Monday, I got sicker than I've been in a long, long time. And I have not quite shaken it yet. I'm getting there though. I'm better than I was yesterday by a bunch. All right, so if X is 0, Y is 5. The Y-intercept is 5. And F of 2, if I look at when X is 2, it looks like Y is also equal to 5. And there's no guarantee on the problem on your final that they'll be the same value. They might not both be equal to the same number. Just be aware of that. Just because one is 5 doesn't necessarily mean the other is 5 also. All right, the next problem we are going to look at is problem 7. Increasing and decreasing. And I do want to point out to you that MyMathLab is very blatant. They tell you that you're going to be describing where this function is increasing or decreasing over open intervals. That means you're only using parentheses, no brackets anywhere in this problem. Okay, so where is this function increasing? It's increasing over its domain. So we always describe this over the domain. It's increasing where it's rising from left to right. And it's rising from left to right from the left to -2. Because at -2, it has a local maximum and it changes direction. So it's increasing from -infinity. It hits -2. It changes direction and starts decreasing. So it's increasing from -infinity to -2. And they do tell me to use commas to separate these. Okay, so the second interval over which this function is increasing, it's increasing again where it's rising from left to right. And it looks like it's increasing from -1 to 0. And my pen has died. Oh no. Yeah. All right, so it's also increasing from -1 to, technology is not my friend today. Try this again. Where is it increasing? From -1 to 0. All right. Then where is it decreasing? Well, everywhere else it's decreasing. This function is never constant. So it's always either increasing or decreasing. So it's going to be decreasing from -2 to -1. And then it's going to be decreasing everywhere to the right of 0. So it's going to be decreasing from 0 to infinity. And again, why isn't that -infinity? Well, because that doesn't make sense. If you're talking about an interval always goes from the smallest endpoint to the largest. That's the way intervals work. So it makes no sense for you to go from 0 to -infinity. Makes no sense whatsoever, because -infinity is infinitely smaller than 0. So why is it positive infinity? Because you're always describing increasing and decreasing over the domain of your function. So where in the domain is your function decreasing? It's decreasing from 1 to infinity. All right, the next problem we are going to look at is problem number 9. And I always say that there are a couple of things that I wish that college algebra students would walk away with. And it's not a lot. I don't ask a lot. One of them is that the domain of a function may not necessarily be the set of all real numbers. I mean, that's the facts. And the other is that when you square a real number, it doesn't matter what the sign of that number is. When you square it, it has to be positive. 2 things I wish people would walk away with. But what's the domain of that function? Well, it certainly could be the set of all real numbers, but I need to investigate. So I need to set that denominator equal to 0. Are there values of x that when I substitute them into that denominator, I get 0 for the denominator? If there are numbers that will make that denominator equal to 0, I must exclude them. They cannot be in the domain of my function. So I'm going to set my denominator equal to 0. And for those of you who are putting in chat that you've had issues logging in, I am recording this and I'll post this horrible video to YouTube later today. And then I will delete it after finals are over because it's not going to be a good video. But I will post that later today. All right. So we're going to set this equal to 0. And then we're going to solve this quadratic equation. I'm going to solve it by factoring. I need 2 factors of 27 that add to 12. I'm thinking that's 9 and 3. Set each one of those factors equal to 0. And I think I get x is equal to -9 and x is equal to -3. Well, the fact of the matter is x can't be -3 and x can't be -9. So those are the 2 restrictions on my domain. Now, how do I write that in interval notation? Well, looking at the number line, I'm going to have a hole at -3 and I'm going to have a hole at -9. Everywhere else is in the domain of this function. Only -9 and -3 are not in its domain. So how do we write that? Well, that would be from -infinity to -9, skip over -9, from -9 to -3, skip over -3, and from -3 to infinity. So we write this as -infinity to -9, union with from -9 to -3, union with from -3 to infinity. Okay. All right. What's the next problem we're going to look at? Number 10, the next problem, literally the next problem. Inverses. How do you find the inverse of a function? Well, to find the inverse, we first replace f of x with y. They're the same thing. And then we interchange x and y. That's what the inverse is. It takes the domain and makes it the range. It takes the range and makes it the domain. So this right here, when we interchange the x and y, that is the inverse. So x equals 2y minus 4 is the inverse. Now, to be able to write this in terms of f inverse of x, I need to solve that equation for y. So I'm going to add 4 to both sides. X plus 4 is 2y, and then divide both sides by 2. And for some reason, my math lab wants it in that form, and I'm not quite sure why. Better put a 2 down there, not an x. I will count it right if you go ahead and write this as 1/2 x plus 2. That's actually probably the better way to write it. Okay, my math lab wants the answer on the left. It wants x plus 4 over 2. Probably the better way, the better form is 1/2 x plus 2, because that is much more the form that we're used to for a line, because both of these functions are lines. The first function f of x equals 2x minus 4 is a line. It's a line whose y-intercept is -4 and whose slope is 2. The inverse is a line. It's a line whose y-intercept is 2 and whose slope is 1/2. So which of the four graphs is the graph of the function and the graph of its inverse? There is only one of them it can possibly be. It is A. It cannot be B. It cannot be C. It cannot be D. Why not? Well, in B, they both have negative slopes. Neither one of those functions have negative slopes. In C, f of x has a negative slope. No, f of x does not have a negative slope. F of x has a slope of 2. In the last one, the inverse has a negative slope. Nope. The inverse has a slope of 1/2. So the only one it can be is A. It's the only one that has the two functions, the function and its inverse with positive slope. All right, what's the domain? Well, the domain of every line in existence is the set of all real numbers. The domain of a line whose slope is not 0 is the set of all real numbers. The domain of our inverse is the set of all real numbers. The range of our inverse is the set of all real numbers. Okay, so the next problem we're going to look at is 13. This is chapter 3 on quadratics, parabolas. Does this function have a maximum or a minimum? It's a parabola that opens down, and I know that it opens down because A is -2. The coefficient on the x squared is -2. So this is a parabola that opens down, and it's going to have a maximum at its vertex. So it has a maximum. Now I need to find its vertex. I'm going to first find x. Using the formula, x is minus b over 2a. So that's minus 20 over 2 times minus 2. I believe that is 5. So the maximum occurs at x equals 5. What is the maximum value? The maximum value is the function evaluated at 5. And I do believe my calculator tells me that is 49. So we have a maximum value of 49 that occurs at x is equal to 5. What's the domain? What's the domain of every quadratic function in existence? What's the range? Well, the range of a function, a parabolic function that opens down, is going to be from -infinity to its maximum, and you better use a bracket next to that maximum. 49 is on the graph of that function, so you do want to include it in its range by using a bracket. Okay, the next problem we're going to do is problem 15, and I do want to read the instructions to this one because it tells you a lot of things you can use to find the first zero. Graph it. Find all the zeros of the polynomial function. Use the rational zeros theorem. No. Too much work. Descartes' rule of signs. Well, you could use Descartes' rule of signs. I don't know that's going to help you a whole lot. And possibly the graph of the polynomial function by a graphing utility as an aid in obtaining the first zero or the first root. That's what I'm going to do. I'm going to graph it. So I'm going to pull out my calculator here. I'm going to go to my y equals, and I'm going to put this in here. So we got x to the 4th minus 16x to the 3rd plus 50x squared plus 152x. Oh, look what I did. Dadgummit. Well, that's annoying. You know, I'm better off just clearing it out and starting over. Try this again. X to the fourth. Arrow to the right. Minus 16x to the third. 16x to the third. Arrow to the right. Plus 50x squared. All right, I'm going to do a zoom standard. So zoom number 6. And it looks to me like my graph is touching at -1. So what does that tell me? If my graph touches the x-axis, that means that 0 is repeated an even number of times. Its multiplicity is either 2 or 4, because this is a 4th degree polynomial. So either we have -1 repeated 4 times, or we have -1 repeated twice. My guess, since we've already done these problems and you had one on your third exam, is that -1 is repeated twice, and the other 2 zeros are going to be complex. That would be my guess. Okay, so now that I know -1 is a repeated 0, I am going to use synthetic division to divide so that I can find the quadratic function and use the quadratic formula on it, a quadratic factor. Okay, so let's go back to our Adobe Acrobat. So I know that x equals -1 is a 0. So x plus 1 is a factor. So I'm going to divide this by -1 using synthetic division. Bring the 1 straight down. I got this is 154. It is 152. And since I do get a remainder of 0, it confirms that -1 is a 0 of this function. I'm going to divide it again by -1. Since I know -1 is a repeated 0. Okay, so bring the 1 straight down. Okay, so now I know this thing factors to x plus 1 times x plus 1, because -1 is a 0 repeated twice, and then x squared minus 18x plus 85. And I'm going to set that equal to 0. And I know that -1 is a 0 repeated twice. So I'm going to solve x squared minus 18x plus 85 equals 0. And I'm going to use the quadratic formula. Okay, so my handy dandy calculator tells me that 18 squared minus 4, I don't know where the 2 came from, I blame being sick. 4 times 85 is -16. And the square root of -16 is 4i. Square root of a negative is imaginary. And then I can divide the 2 into the 18 and into the 4. So I forgot my minus here, plus or minus. So because it's a factor in both 18 and 4, I can divide both of those by 2 So x is 9 plus or minus 2i. So what are my zeros for this function? My zeros are -1, 9 minus 2i, and 9 plus 2i. I don't know where my braces went. They got lost someplace. All right, next problem we're going to look at is problem 17. And this is one of those problems that I know, looking at what you did on your exam, that you guessed. And you know, that's okay. I don't know how many of you have seen the movie Indiana Jones and the Last Crusade, where the Knight Templar tells the guy, you guessed poorly. You either guess well or you don't. So, you know, if you want to guess, then be aware that you may guess incorrectly. So how do you do this problem? Well, you have to find the boundary points. And then the boundary points break the number line into intervals. And then you test a point in the interval to see if the inequality is satisfied. And if you know that it's satisfied for one point in that interval, it's satisfied for all the points in that interval. So you first find the boundary points by setting this equal to 0. And I'm going to factor it. I think we got a plus and a minus. So x is 1/2. Add 1, divide by 2. X is -5. Okay, so what are my intervals then on my number line? And we have less than or equal to, so we're going to use brackets. Okay, so now I set myself up a little table. I'm going to do that down here. So I'm going to set up a table with the interval. I'm going to pick a test point in each of these intervals. I picked -6, 0, and 1. Excuse me, you just need a point that's in that interval. And then you're going to evaluate the function at that point. And I don't want to be a nudge, but there is no reason whatsoever you should not be able to evaluate a function using your calculator and get it correct. Right, then you're going to look at what the sign is. It's positive here, positive 13. It's negative here, -5. And it's positive here, it's 6. So what are we interested in? We're interested in where this thing is negative. Where is it less than or equal to 0? So we are interested in where it's negative. So where is it negative? It's negative between -5 and 1/2. So that is the solution. Which graph is that? Well, that looks like that's F. Between -5.5. Okay, so the next problem is, if you couldn't do that one right, well, let's give you another one. Problem 18. And it works the same way, except in a rational function. There are boundary points formed by where the numerator is equal to 0, so where it crosses the x-axis. But there's also a boundary point created by the asymptote, the vertical asymptote. So the boundary points are the values that make the numerator 0, so actual zeros of the function, and where the denominator is 0 or the vertical asymptote. So my boundary points, setting the numerator and denominator equal to 0, we get -11, 13, and -9. So what are my intervals? So we have -11, -9, and 13. So I have from -infinity to -11, and I'm going to use a bracket there because we have less than or equal to. Then I have from -11 to -9, and I am going to use a parenthesis next to the -9. The denominator cannot be equal to 0, so I have to exclude -9 from my solution. So I just put a parenthesis next to it. So I have -9 to 13, put a bracket next to the 13, parenthesis next to the -9, and then from 13 to infinity. Okay, so I'm going to go set up myself a table down here. Do that right here. So we have from -infinity to -11. -11 to -9, -9 to 13, bracket next to the 13, and 13 to infinity. Pick a test point. I picked -12. -10 is between -11 and -9. 0 is between -9 and 13, and 14. Now I'm going to evaluate the function at each of these values. And there is no excuse for not being able to do this on that calculator. None. None. So if I evaluate that function at -12, I get -25/3. And it doesn't matter if you write it as a fraction or a decimal. All I'm concerned with is what the sign is. And the sign is negative. And when I evaluate this function at -10, I get 23. That is positive. When I evaluate this function at 0, I get -143/9. That is negative. And when I evaluate this function at 14, I get 25/23, which is positive. Okay, so what am I interested in again? I'm interested in where it is negative. Where is it negative? It's negative from -infinity . Should probably write this someplace where I can make room for my other problem. From -infinity to -11, and from what? -9 to 13. That's a union symbol, not very neat union symbol, but that's what it is. Okay, so what graph is that? From -infinity to -11 with a bracket, and from -9 to 13 with a parenthesis on the -9, that is F. All right. The next problem we are going to do is problem 20. Write the equation in its equivalent exponential form and then solve for x. So what is its equivalent exponential form? The base is 5. Whatever your log is equal to is your exponent. So it's going to be 5 squared equals x minus 1. And that's all you need to write. 5 squared equals x minus 1. You don't need to go any further. That's what you need to write. So in terms of the base, exponent, and then the whatever the logarithm you're taking. All right, then you solve that. I think that's going to be 26. 25 plus 1 is 26. Okay, condense this logarithm. So I have factors outside of the logarithm. I'm going to bring those in as exponents. You have the quotient rule that says if you have the difference of two logarithms, you can write that as the logarithm of the quotient. So this is the natural log of x to the 6th over y to the 5th. All right, the next one we're going to do is problem 22, the match base problem. So I need to write, if I want to match the bases, I need to write 1 over 16 as 4 to the something. Well, 1 over 16 is 1 over 4 squared. And 1 over 4 squared is 4 to the minus 2. And so now I can equate the exponents. So I have 4 to the 2 minus x is equal to 4 to the minus 2. Set the exponents equal to each other. And solve the resulting equation. So I'm going to subtract 2 from both sides. Divide both sides by -1. So x is equal to 4. 4 is the solution. All right, problem 23. How am I doing on time? I'm doing well. This is the problem that on the chapter 4 exam, I don't know what app students are using, and it is certainly across the board. And it's been across the board all the semesters I've been teaching college algebra out of this book. So somehow you're using some app. I don't know how you're doing it and getting away with it, but the answer is wrong. The answer this app is giving you, whoever you're doing it, the answer is wrong. So many people got this problem incorrect. And it's just like, trust yourself, don't trust the app. I'm not kidding. And if you even got it remotely where it looked like you were using something, I did not give you credit. All right. How did we do this in class? To solve an exponential equation where you have e being raised to the something, you're going to take the natural log of both sides. If you've got e as your base, then it just makes sense. I'm going to take the natural log because the natural log is the inverse of base e. But the first thing I got to do is get rid of the 5. I can't do this until I have the e to the 2x isolated. So I'm going to divide both sides by 5. And my handy dandy calculator says that 3,155 divided by 5 is 631. So we get e to the 2x is 631. And now I just take the natural log of both sides. And the natural log of e to the 2x is just 2x. And this is where I know something weird's going on, because everybody has the same exact wrong answer. So the wrong answer I'm seeing is 2 log base e of x is the log base e of 631. And there is never in the entire history of me teaching you stuff where I ever wrote it like that, ever. So where that came from, does that come from? Did they do that in that? Help me solve this? Where does that come from? I haven't a clue. I never did that. Okay, what's the natural log of e to the 2x? It's 2x. The natural log of e to the 2x is 2x. The natural log of e to the anything is the exponent. So I don't know where that came from. If you're using that app, stop using it because it's giving you an incorrect. And that's where you stopped. Okay, now it won't let me erase it. Get off here. Erase. Okay, so the natural log of e to the 2x is 2x. So we get 2x is equal to the natural log of 631. We divide both sides by 2, and we get x is the natural log of 631 divided by 2. So that is the first part of this answer, the natural log of 631 divided by 2. Then you take your handy dandy calculator out and you take the natural log of 631 and you divide that result by 2 and round it off to 2 decimal places. Please follow the instructions. 3.22. All right, the next problem we're going to do, as you can see, is problem 24, solving a logarithmic equation. And this one, we have multiple logarithms on the left-hand side of the equation. So we do want to condense that to a single logarithm so that we can then write it as an exponential. That's how we solve these type of problems. So I'm going to go ahead and I'm going to go ahead and condense this logarithm by using the property of the sum of two logs can be written as the log of the product. So we can write this as log base 12 of x times 11x minus 1. And that is equal to 1. And now we write this as an exponential. Our base is 12. We're raising that to the first power. This is my exponent. And that's equal to what we're taking the log of. And that's going to be quadratic. So I need to get it in the proper form so that I can either factor it or use the quadratic formula. So we get 12 is 11x squared minus x. I'm going to move the 12 over to the right-hand side. I get 11x squared minus x minus 12 is equal to 0. I am going to factor this. I think the 12 goes there, the 1 goes there, a plus and a minus. So it's 11x minus 12 times x plus 1. Set each factor equal to 0. Add 12, divide by 11. Add 12, divide by 11, subtract 1. -1 is not a solution of this. -1 violates the domain of the logarithm. You cannot take the logarithm of a negative number. So -1 is an extraneous solution. So the solution is 12/11. All right, we're almost done, folks. 3 problems left. Solve, and you have this particular problem on your 5th chapter exam, the chapters 5 and 6 exam. Solve the system by the method of your choice. So what do we have here? We have a nonlinear system. And it's nonlinear because that first equation contains an x squared and a y squared. As a matter of fact, FYI, just between us, that first equation is an ellipse. So we have an ellipse and the second equation is a line. So where can an ellipse and a line intersect? Well, they can intersect at 2 different places. So looking at this problem, how do I think I want to solve this? Well, I am going to use substitution, and I'm going to solve the second equation either for x or for y. And I'm probably going to choose to solve the second equation for x, not y. Why? Because of that 2 in front of that y squared, if I solve that second equation for y, I have to plug that in, square it, and multiply it by 2. So I just think it will be easier for me if I solve for x in the second equation and then substitute into the first equation. So that's what I'm going to do. I'm going to subtract y from both sides and solve this for x. Now I'm going to plug that in for x in the first equation. So I have 30 minus y squared plus 2y squared is equal to 900. Okay, I must square that binomial. And how do you square a binomial? You take the first term, which is 30, and you square it. 30 squared is 900. Then you take the two terms, the 30 and the minus y, you multiply those together, you get negative 30y, and then you multiply that by 2. So that's going to be negative 60y. Then you square the negative y squared. Negative y squared is just y squared. It looks like the 900s are going to subtract off. So I end up with negative 60y plus 3y squared. Combining like terms, I have a y squared and a 2y squared. That gives me 3y squareds equal to 0. All right, that is quadratic. It doesn't have a constant term. So I'm going to factor it by factoring out the greatest common factor, which I think is going to be 3y. So I'm going to factor out a 3y. That's going to give me negative 20. 3y times negative 20 is negative 60y plus y. All right, now we're going to set each one of those equations equal to 0. So we get y is equal to 0, divide both sides by 3. Or we get what? Add 20 to both sides. Y is equal to 20. So either y is 0 or y is 20. Well, then what's x? Because the solution to this nonlinear system of equations is going to be two ordered pairs. So if y is 0, plugging that back into the x is equal to 30 minus y, x would be 30. So the first ordered pair would be 30, 0. What's the second ordered pair? Well, if y is 20, plug that back in. 30 minus 20 is 10. So x would be 10. So our two ordered pairs would be 30, 0 and 10, 20. Okay, number 28. Graph the solution set of the following system of inequalities. Okay, I'm going to graph each line, and just looking at this, I'm thinking that intercepts would be the easiest way for me to graph this. That is certainly not the only way to graph it. I mean, you can graph it by plotting points. You can graph it by solving for y and using slope and intercept. Whatever you're comfortable with, go ahead and use that. I am going to use intercepts because it just looks like that it's going to be really easy to do. So I'm going to graph the first line. And both of these are going to be solid because I have less than or equal to on both of them. So the x-intercept is going to be 2. The y-intercept is going to be 1. And how do I get that? I just set x equal to 0 to get the y-intercept and y equal to 0 to get the x-intercept. So we have x is 2 and y is 1, and we're going to draw a solid line. Let's see if I can do that. Okay, not perfect. Now I'm going to graph the other one. The x-intercept is going to be 2. And the y-intercept is going to be 8. Okay, oh, that's terrible. Use your imagination. All right, so now we need to determine where we shade. So do I shade to the right? Do I shade to the left? What do I do? So pick a test point and check each inequality. And the easiest test point to pick is 0, 0. So it's always the one I pick if I can. If the line doesn't go through 0, 0, then that's the test point I'm going to pick. Okay, does 0, 0 work in the first inequality? And the answer is yes. 0 plus 0 is less than or equal to 4. So I would shade below, if you will, to the left of that first line. So below that first line. Does 0, 0 work in the second? And the answer is yes, it does. 0 is less than or equal to 8. So I would shade below that one. So where would those two shaded regions intersect? They would intersect below both lines. So in here. So for the first line, it's below that line. For the second line, it's to the left. So where would those two regions intersect? They would intersect where I have shaded. Last problem. Woo! Yay! Last problem of the semester. Use Kramer's rule to solve the system. To be totally honest with you, I don't really care how you sorry, how you solve it. But Kramer's rule is just as good as anything. I personally think Kramer's rule is easier than solving using addition. That's my humble opinion. So what do we need to do to solve this system using Kramer's rule? We need to find 3 determinants. The first determinant we need to find is the determinant formed by the coefficients on the x's and the y's. So we call that determinant D. That is the determinant of the matrix formed by the coefficients on x and y. Okay, so what is that determinant? That determinant is we take 4 times 3 and we subtract from it the product of the other diagonal. So we subtract 3 times -5. So that is 12 plus 15, that is 27. So there's our first determinant. The second determinant we find is D sub x. And D sub x is the determinant of the matrix where we take that matrix D, that determinant D, and we replace the first column with the constants. So we take the constant 6, 18, and we make that the first column. So our determinant is 6 times 3 minus 18 times -5. So that is 18 plus 90, that is 108. The next determinant we find is D sub y. That is the determinant of the matrix formed by taking the coefficients on the x's and y's and replacing the y's with the constants. So that is going to be 4, 3, 6, 18. So that is 4 times 18 minus 3 times 6. That is 72 minus 18, which is 54. So now that I have my 3 determinants to find x and y, I'm going to have to write it up here because I ran out of PDF. So x is D sub x divided by D. So that is equal to, what was D sub x? D sub x is 108 divided by 27. I believe that is 4. Y is D sub y divided by D, which is 54 divided by 27, which is 2. So the solution to this system of equations is 4, 2, the ordered pair 4, 2. And we can do a quick check of that. 16 minus 10 is 6. That works in the first equation. 12 plus 6 is 18. It works in the second equation. All right. And that is it. Okay, let's go back. I know some of you came in late. I am recording this. I did record this. I am going to stop the recording now.